Hello, Math 133 students. I received a request for help with this problem, which is 8.2.21t in my stat lab. Of course, where it is in your particular homework assignment might vary. All right, so I'm going to view an example, which will, of course, work very similarly to this. So exit polling is a popular technique used to determine the outcome of an election prior to results being tallied. So basically, as you exit the polling place, they ask you who you voted for, and you tell them, and therefore that's what exit polling is. It's literally as the voter exits the polling area. All right, suppose a referendum to increase funding for education is on the ballot in a large town with a voting population over 100,000. An exit poll of 700 voters finds that 343 voted for the referendum. How likely are the results of the sample if the population of proportion of voters in the town in favor of the referendum is 0.52. Based on your results, comments on the dangers of using exit polling to call elections. Okay, so boy, there's a lot to unpack there. All right, so I started by copying all of this over to another document just so we can work with it here. So let me see if I've got it right there. There we have it. All right, so we're going to start with how likely are the results? That's a probability question. So when it asks this, how likely are the results, then we're going to have to answer that with probability. One of the things we want to know to prove that we can use probability is we need to know that this is normal. Oop, I just pressed the wrong button. There we go. Normal. So I'm just going to ask this. It wasn't part of the problem, but remember that in order to be normal, we need our sample size times our proportion. Here, hold on. Equation. There it is. We need n times p hat. So n times p hat times q hat. So I'm using the equation editor here. Times q hat to be greater than or equal to 10. That's what we want to prove. All right. So n for this group is right here. So n is 700. Actually, I'm going to make a little note of that right here. So n is 700 right there. So let me highlight that in like blue or something here. And I'll just make a little note right below this that n is 700. Oops, sorry, it's being really annoying with me right now. There we go. N is 700, right? So that comes out of the exit poll of 700 voters. So that's our sample size, 700. Which, by the way, we can also tell offhand that this is independent because 700 is way less than 5% of 100,000. So we also know this is independent. And they say it's, well, we're having a little bit of issue with perhaps randomness, but that'll be another issue. All right, so then we also can tell that X is 343. It's the 343 that they gave us. So X equals 343. That is going to be in pink. There we go. So that's 343 right here. Okay, so then I can use that down here, right? Because I can find p hat from that x and that n. So I can say, okay, well then I know that my p hat, here, let me make this none here. P hat would be x over n. So p hat equals x over n, which is 343 divided by 700, which is approximately, I don't know, but I can find it real quick. All right, so that would be approximately, let me grab Desmos. 343 divided by 700 is 0.49. Okay, so that's equals 0.49. It's not even an approximate. All right, so then I can use that fact down here. Let me make this a larger font just so we can all see it a little bit better. If I can get Google to play nicely with me here. All right, so let me make this a little bit bigger too. So I actually know it's normal, and I'm gonna prove it's normal, and I kind of know it's independent as well. So just for fun. So this would be n is 700 times, there's the times dot, 0.49 times the complement of 0.49 is 1 minus 0.49, which is 0.51, right? Of course, because 1 minus 0.49 is 0.51. And then I can see I'm going to have to multiply this. So 700 times 0.49 times 0.51, 0 right there, is 174.93. And 174.93 is in fact greater than 10. Greater than or equal to 10. So yay. That's great, because the reason we're doing this, even though the problem didn't strictly ask for it, was we need to know it's independent and normal and all of that stuff in order to be able to use the normal curve. And technically I can also tell that n, which is 700, is less than or equal to 0.05 times capital N, and capital N is my 100,000, right? So 1, that's 10,000, there's 100,000, right? So if that's the case, then I'm good, right? So 0.05 times 100,000 is 5,000. So yep, we are a-okay, right? This is totally fine. So yes, this is good too, right? So there's capital N, there's lowercase n. So I proved it's independent and normal, and that means that I can use the normal calculator to be able to find my probability, right? Because I want to know how likely are the results. So I want to know the probability of, let me make my font larger. I want to know the probability that p hat would be the exit poll value of what we got. And here's the problem that I'm having. They ask about how likely the results are, but then they don't give us a direction. We're technically in a continuous distribution, so we actually need a direction, because the probability of this specific p hat is 0, right? Any specific p hat is 0. Sorry, I'm trying to get this to work with me, and it's not playing nicely. All right, so p hat, and we need to know what direction. Are we talking about greater than 0.49, or are we talking less than 0.49? Which way are we talking here, right? So for that, you actually have to go back to your problem. So they write it, because they kind of cheat, because they have to give you a direction. So it says it right here. It says fewer than 343 people right there. See that? So we're going to use that. So you have to use that fewer bit. They will write it in the problem for you. They will either say more than, or they will say fewer than. So you'll have to kind of adjust it based on this. So they kind of add this piece into it, probably that fewer than 343. So they made it a fewer than problem right there. So go to your problem and see if you're doing fewer than or more than. It's just going to change which direction you make the probability calculator go. Okay, now when I go to do this, I want to use my StatCrunch probability calculator. So I want to be able to go to Stat, Calculators, and Normal, and use that calculator. The problem is that, for this particular one, I'm doing a fewer than, so it's going to be a less than. If you're doing a more than, you'll make it more than. So that's all well and good. The problem is I need a mean and a standard deviation, right? I know that I'm talking about 0.49. That's great. So I know that it's less than 0.49, but I don't know my mean. So let me go back and look at the problem again. It doesn't really matter where I go. I'll go here, right? So, because I have it written up. All right, so we know this, we know this. So now let's look at the values they gave us. They tell us right here that you assume the population proportion is 0.52. It just occurred to me they probably wanted you to use 0.52 here for this piece. It doesn't matter. It's fine. All right, so right here, they're telling us P is assumed to be 0.52. Let me give that a highlight color of orange. All right, so note, P is 0.52 is given, right? That's our population proportion. So in order to figure out this probability, so if I'm in StatCrunch, by the way, I know the mean. The mean is 0.52, right? Why do I know that? Because of section 8.2, the central limit theorem. So here, let me write this. My central limit theorem for proportions, which was section 8.2, because I have the independent and normal business, and P is 0.52, then I actually know, I'm going to have to give myself a little more space here. I actually know the center, the shape, and the spread. So the shape, if you remember, is normal. We actually just proved that up here. Although, again, they probably would have used the 0.52, but tomato, tomato. So shape, center. The center is the mean of the p-hats. The mean of the p-hats, and you can find this in your notes in section 8.2. It's the central limit theorem. So it's the mean of the p-hats is equal to p, but p is equal to 0.52, right? They gave it to us. It's right here, right? So we proved it was independent. We proved it was normal. That means we can use the central limit theorem. Then we can use the central limit theorem for proportions, and we know shape, center is going to be 0.52, so that's going to be my mean. And then the spread, that's the hard one, right? So that spread is the sigma of the p-hats, the standard error of the p-hats. So let me go in here. And there's a formula for it that we learn in section 8.2. So sigma of p-hats, also known as the standard error of the p-hats. You can write it that way as well. That's kind of the more modern notation for that. All right, now the formula for it is involved. It's a big square root with a fraction around it. So let me put square root, right? So then it's p times q. Whoops, I lost my fraction. Hold on. P times q, p times q divided by n. Now p is 0.52, so we're going to say it's the square root of 0.52 times the complement of 0.52, which is 0.48, divided by n, which was 700 for us, right? N is still the 700 that we found up above. And we grab Desmos or grab a calculator and we make it do that. So let's see here. So I'm going to take down here square root, and you can either type SQRT, it'll bring up the square root, or you can bring up this little number palette and it's right there. It's the square root. And you could say 0.48 times 0.52 divided by 700. And it actually doesn't matter, by the way, people have asked me this in class. You can do 0.48 here, 0.52 times 0.48 divided by 700, same answer. Or you can do here, parentheses 0.52 times 0.48, close parentheses, divided by 700. It's the same thing every time. So it all works, and it only works that way because it's all multiplication and division. If there was adding in there, that would be a different story. But because it's all multiplication and division, it doesn't really matter which way you go. All right, so it's 0.01888. So that's going to be our spread. So I'm going to put an approximation over here because it's approximately 0.0. Whoop, I'm still underneath that square root. I got to get out of there. 0.01888. So that's what we use for our spread. So over here, we're going to use 0.01888. And then I'm going to click compute. So I've got it less than, because they said to do fewer than, 0.49. And there we have our probability right there. 0.056. 0560, if you will. So the probability with, and then I'll make a little note. So to use this, I got rid of too much. So note, use stat, and then calculators, and normal in StatCrunch. You could also do this in a calculator with the normal CDF function if you wanted to. And we get that this value is approximately 0.0560. That was the actual number that they wanted an answer for right there. So it said, how likely are the results? That's your answer. That's how likely the results are. Okay, so let's go back over this real quick. We've used the original problem. We get our x and our n. We get a p hat from that, which is our sample proportion, which is 0.49. Then they also gave us a p-value of 0.52, and we use that in order to find shape, center, and spread, right? So by the central limit theorem of proportions, we know shape, center, and spread are right here, right? Those pieces are from there, and we're allowed to use that because we know it's independent and normal, right? So we're going to grab that. Now, as for the final bit, because then they ask you, based on your results, comment on the dangers of using the exit polls. So let me get some of the possible answers that they give you. All right, I've copied and pasted in the kind of answers they're going to give you. So the first thing to note is you want to look at your probability and figure out whether that's less than 5%. Because if it's less than 5%, that's unusual. If it's not less than 5%, which it's not in this particular example, then it's not unusual. Now, it might be different for your problem. So look over your problem and see, like, hey, is my number less than 5%, less than 0.05? Then I'll look for the unusual ones. And if it's not less than 5%, then I know it's not unusual. So this part right here where it says the result is unusual, I can just cross that one off right off the bat. Like there's no way that is right. So let me cross that one off, strike through. And this bottom one right here, strike through, because it says this result is unusual. So there's no way that is right. Oop, I did that wrong. Alt Shift 5. There it is. I knew there's a cat key. All right, so those ones said unusual. This for me is not unusual, so that's not good. So I'm going to have to go with a not unusual. So it's not unusual because 0.056 is greater than 5%. Well, the difference to these answers is right here. Not unusual, blah, 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 blah. And then right here, see how this one says less than right there? And this one says greater than right there. So you got to analyze what they're giving you. So the first two, A and D, I can throw out. And of course, you know the order on these is going to shift, right? It rotates them around. So look through your problems really thoroughly. But if your number is bigger than 5%, you're going to cross off the unusual ones, leave yourself only the not unusual ones. And then you got to analyze it further. This one is greater than 5%. So this is the right answer. Ding, ding, ding. And the other one is wrong because it said less than, and that's not right. So boo to that one. Okay? And that'll be it. I think that is all you need for that question. So it's a little bit complicated up here. Technically, you don't have to do the independent normal thing. Technically, I did it wrong because I should have done P and Q instead of P hat and Q hat, but whatever. But what you do need is a center built off of that 0.52 and a spread. So look for that population value given to you. Figure out your center and your spread. Then figure out what direction you're going. We were going fewer than. My goodness. Because it said fewer than. So I'm going to go fewer than. I'm going to go less than. So less than 0.49. If it's greater than for you, then do a greater than. And then figure out what you're doing from there. All right, I hope that helps.